Okay. The next thing that we need to do is to look at the law of cosines. And I think I mentioned this before, but at this point in your mathematical career, you need to understand where some of these formulas are coming from and to get an idea of how these concepts relate, where these things come from, because the higher level math you get, the more you're going to have to prove stuff. Right, so this is my proof of the law of cosines. Now, there is more than one way that you can come up with this formula. This is the way that I think is one of the easier ways for y'all to understand the algebra in it and understand where the process comes from. I'm going to start off with the coordinate grid. I'm going to make quadrant 1 really big because that's where I'm going to put my triangle. So I have this obtuse triangle. I'm going to call this point A, this point C, and this point B. No matter what obtuse triangle you have, you can turn it around and flip it upside down and move it left to right, up or down, and put it in quadrant 1 to where it looks like this. Okay. And what I'm going to do from here is to drop this perpendicular line down. I need to label this as side A, this is side B, and this whole length here of this triangle is side C. Now, this should look sort of familiar to y'all for those of you who did that bonus problem way back when, I think it was on the first test, we had a problem very similar to this. And a lot of y'all started that bonus problem off correctly by dropping your perpendicular down. But I believe on that problem, your base was 500 and y'all said this length was 250 and this length was 250. But this perpendicular line does not necessarily bisect this base to cut it into 2 equal sections. So we're going to look at exactly what's going on with the lengths of these 2 sections. Now, this point C is some point X, Y, right? An X coordinate, a Y coordinate. The length of this part of my triangle is X, and this height is Y. Because this is the point XY, that means you go over X unit up Y units. Now, this whole side here on my triangle has this base being length C. If this side is X, this length in here would be C minus X. So on your bonus problem that we did way back when, that's what you should have done for that expression of those 2 bases. Let's say this one is X and this one was 500 minus X. Okay. Now, just to make things a little bit easier to see and talk about, I'm going to highlight that, make that yellow triangle. That's a right triangle. And this is in pink. That is also a right triangle. Now, what I'm going to do is use the Pythagorean theorem for both of those triangles. So on the left-hand side, you have you normally say a squared plus b squared equals c squared, but my a and b are not in the right triangle. So it's the 2 legs squared equals the hypotenuse squared. So let me write this here. The Pythagorean theorem for my yellow triangle is going to be x squared plus y squared equals b squared. And then I'm going to do the Pythagorean theorem for my pink triangle. You could call it left triangle and right side triangle if you wanted to. So my two sides here are c minus x squared plus y squared equals hypotenuse squared or a squared. Now, what I've done so far is nothing really complicated. Right? I've drawn in this height of this triangle, and I've gotten expressions here. So that might be something that y'all did in high school geometry, but may not have thought about since then. It's getting an expression for these two lengths. Using the Pythagorean theorem, it's nothing complicated. We've been using the Pythagorean theorem all semester long. Now I'm going to go ahead and multiply this out. So this would be c squared minus 2cx plus x squared plus y squared equals a squared. And then what I'm going to do is to take this part right here, this x squared plus y squared, which is what this is, and I'm going to substitute in b squared. So I have c squared minus 2cx plus b squared equals a squared. So I'm just going to switch this around, flip-flop sides. That's called the symmetric property of equality. So over here on the left-hand side, I'm going to have a squared. Over here on the right-hand side, I'm going to put this in a different order. I'm going to say b squared plus c squared minus 2cx. Okay, so this is looking a lot better. I don't want to have an x in this problem. I want everything to be in terms of the lengths of my original sides, lowercase a, b, c, or one of my angles, uppercase a, b, c. So the only thing I have to do is to get rid of this x. Well, if I look back to my yellow triangle here, I know that I can relate this x, write a relationship with this x and the cosine of angle A. Okay. Cosine of angle A is adjacent over hypotenuse, so x over b, adjacent over hypotenuse. So x would be b cosine of A. So now I can replace this x with b cosine of A. So I have a squared equals b squared plus c squared minus 2 times c times b cosine of A. And I'm going to drop the parentheses and rearrange these two letters here just so they can be in alphabetical order. So I've just proven the law of cosines. And did it really matter which one was, A or B? No, I could change my triangle, turn it around and reorient it and then do this whole thing again. And I can come up with an equation for a squared, an equation for b squared and c squared. So that's where the law of cosines comes from. And you've got 3 different versions of that.